Hello children, today we will be discussing about trigonometry, and this is a topic of class 9 wherein we will be looking up the solution of a triangle. Now when we talk about the solution of a triangle, we mean to say that we want to find out everything which is possible of a triangle. That means all the three sides and all the three angles. Although whatever will be asked to you in the question, only that you will have to find out. And this has to be done by using the trigonometric ratios. You know that we have 6 trigonometric ratios of sine, cos, tan, cot, sec, cosec. So we will first look up these formulae, and after that we will be looking up what are the ones which have to be found out in accordance with the question, and then we'll get along with it. I'm sure I'm going to make you very comfortable in this topic, but for that you require to focus completely, sitting on a table and chair and making sure that there is no disturbance by your side, and then you can rest assured that this topic is going to be fully strengthened. So let's get started children, and let's look up what we mean by solution of a triangle. So when we talk about a triangle can be, say, something like this. That is, it can be, say, this, which can be said to be a triangle. However, if you talk about this to be a triangle having, say, the different vertices to be P, Q and R, then we are not able to find out the trigonometric ratios using such a triangle. What we require to do in such a triangle is there should be some vertex from which we require to drop a perpendicular. Only then we will get a right angle triangle, and then we are able to find out the 6 trigonometric ratios that I just mentioned. So if you have such a sort of a triangle, what you will do is from any one vertex you will be dropping a perpendicular. So let's say we talk about this vertex P from which a perpendicular is dropped, say something like this. Now we have 2 right angle triangles, and let us consider that this point where the perpendicular has been dropped is D. So as such, now we have one right angle triangle, that is this, and another right angle triangle, that is this. I'm sure all of you know that whenever we have a right angle triangle, then the Pythagoras theorem applies, right? And what does the Pythagoras theorem tell you? It tells us that if we have a right angle triangle, then we have the largest side square to be equal to sum of the squares of the other 2 sides. So the Pythagoras theorem is what I told you just now. In times to come, we will have another lecture fully devoted to Pythagoras theorem, where we'll be proving the Pythagoras theorem, and we'll also be looking up sums with it, right? So at this time, what we do is the side which is in front of 90, that is the largest angle possible in this right angle triangle, is the largest side, and that, children, is the hypotenuse, right? And then the side which is opposite to an unknown angle, let's say theta, or if it can also be a known angle, probably you have been given the value of this angle, then the side which is opposite to it is known as the perpendicular, and the third side becomes the base. For that matter, there's something different. Now if we talk about, say, now the other angle being taken, let's say we talk about now this angle, right, which is taken, and let's say this angle is phi and theta, both are Greek alphabets, then the side which is opposite to this angle will be said to be the perpendicular, and the side which is opposite to 90 will always be said to be the hypotenuse, and the third side will then become the base, right? So as such, the base and the perpendicular change in accordance with the known or the unknown angle. You got to remember that in front of the known angle you have the perpendicular, and the third side will become the base, as the side which is in front of 90 will always be the hypotenuse. So I will just quickly repeat all of this. If you have a right angle triangle like this, right, already in the question, then that's fine. If it is not there in the question, then from any of the vertices you got to drop a perpendicular, and then you will get a right angle triangle. And in that right angle triangle, what you will be doing is the side which is opposite to 90 degree is the hypotenuse, the side which is opposite to the known or the unknown angle is the perpendicular, and the third side will become the base. So if this be the known or the unknown angle, the side which is opposite to it will be what? the perpendicular, right? The third side will become the base, as the side which is opposite to 90 will always remain to be the hypotenuse. So here we had two cases, one of angle theta, another of angle phi. Both were written with different colors so that you can easily identify, and thus we had the perpendicular, the hypotenuse, and the base for both of these angles, theta and for phi, right? Okay, now that you are clear about what is going to be the perpendicular, what is going to be the base, now we will come over to applying what the Pythagoras theorem is. And that, children, tells you, like I told you, the largest side, that is the hypotenuse squared, right, is equal to sum of the squares of the other two sides. And here we have the other two sides to be the perpendicular, right, and it's going to be squared, and to it is going to be added base square, right? So this is the Pythagoras theorem, which applies to a right angle triangle, and we'll be using it every now and then to find out one of the unknown sides, right? Now, children, the 6 trigonometric ratios. So if you talk about the trigonometric ratios, they are 6 in number. The first is sine, and of an angle theta, it is perpendicular divided by hypotenuse, and its inverse is cosec theta, right? So for the cosec theta will become equal to hypotenuse upon perpendicular, and that is the reason when you talk about its inverse will become equal to perpendicular upon hypotenuse, right? So for the children, next what we can do is we can now talk about the next thing, that is cos theta, right? And if you talk about cos theta, then that is equal to base divided by hypotenuse, and that is the inverse of sec theta. So as such, 1 upon sec theta can be said to be cos theta, or sec theta can be said to be 1 upon cos theta, right? Now after this, the next trigonometric ratio that we have is tan theta, and tan theta is perpendicular upon base, and as it becomes perpendicular upon base, and we can get perpendicular upon base by dividing sin theta by cos theta, as such tan theta is also written as sin theta divided by cos theta, right? And further, you have it to be equal to 1 upon cot theta, as the inverse of tan theta is cot theta. Thus, if you want to write the value of now cot theta, so cot theta will become equal to base upon perpendicular, sec theta will become equal to hypotenuse divided by base, and cosec theta will become equal to the inverse of sine, that is hypotenuse divided by perpendicular. So these are the 6 trigonometric ratios that we have, and in accordance with a right angle triangle, we will be given certain measurements of the triangle sides, and that when we put up, what do we get? Can anybody tell me? Yes, can you tell me? Yes, Simran. Yes, Rajat. No? Well, as you see that on the left hand side we have an angle, and on the right hand side you have the ratio of the sides. So as such, this relation gives you a relation between the sides and the angles of a triangle, right? So this is what a trigonometric ratio is, and this is the reason why it is pretty significant and important. That is because it relates the angles with respect to the sides of a triangle, right? So this is what a trigonometrical ratio is. It relates the sides and angles of a triangle. Okay, now that we have all of these 6, I will provide a quick revision to you people, and after that we will get along with the special sum that I have for you people. So children, the first thing that we discussed was that when we talk about trigonometry, and in it when we talk about solution of a triangle, we actually talk about a triangle's 3 sides, and we want to talk about also about the 3 angles of the triangle. So finding out the 3 sides and the 3 angles of the triangle will give us the solution of a triangle. That means that is all that a triangle has to offer. Alright, now if you have a normal triangle which does not have a 90-degree in it, what you require to do is from any of the 3 vertices you require to drop a perpendicular, and when you drop a perpendicular, then now you will be having a right angle triangle, and in it if one of the angles is known or unknown, the side which is opposite to it will become the perpendicular, the side which is opposite to 90 degree will become the hypotenuse, and the third side will become the base, right? So whichever angle you choose, you can take it except the one which is 90 degree to be the known or the unknown angle. Then all of these things are going to happen. We looked it up for theta. When theta was the known or the unknown angle, the side which is in front of it in blue ink was the perpendicular. In front of 90 degree in blue ink we have the hypotenuse, and the third side in blue ink again is the base. Now if this known or the unknown angle is phi, so in front of it we have perpendicular in purple ink to be the side which represents the perpendicular. The side which is the hypotenuse remains to be the same again in purple ink in front of 90 degree, and the third side in purple ink will become the base, right? So this is how, in accordance with the angle, you can be having different perpendicular or different base in the same right angle triangle. Now that you are clear about this, we will move on to the next concept, that is the Pythagoras theorem. So whenever you have a right angle triangle, then the Pythagoras theorem tells us this, that the largest side square is equal to sum of the squares of the other two sides. So as such here, the largest side being the hypotenuse, its square is equal to sum of the squares of perpendicular and base, which are the other two sides. Now next we have the 6 trigonometric ratios. The first is sine theta, which has been abbreviated as SIN, but actually it is SINE, right? Theta is equal to perpendicular upon hypotenuse. It is the inverse of cosec theta. As such, if you find out the invertendo of cosec theta, or in other words the inverse, then you will be able to get to sine theta. Now cos theta has its value to be base upon hypotenuse, where cos is actually the abbreviation to cosine, right? And its inverse is sec theta. As such, 1 upon sec theta will give you cos. Now tan theta is actually tangent theta, and it's equal to perpendicular upon base. Now as perpendicular upon base can also be had if you divide sin theta by cos theta, and as such sin theta upon cos theta becomes equal to tan theta. And thus here, if you talk about tan theta, you can even write it to be by its inverse, that is 1 upon cot theta, because cot theta is its inverse. So if you invert it again, then you will be able to get to tan theta. Next children, we have cot theta. So directly writing out the value which is the inverse of tan theta, that is base upon perpendicular, and sec theta, which is the inverse of cos theta. As such, it will become equal to hypotenuse upon base, right? And cosec theta, as it is the inverse of sin theta, it will become equal to hypotenuse upon perpendicular. So these are the basic formulae that you're going to remember, and if any of the sides are not present, then obviously the Pythagoras theorem is going to help us to find out the unknown side, right? Now children, one thing more, I told you that as these are the trigonometric ratios, the speciality is that they are those ratios which help us in finding out a relation between the sides and the angles of a triangle, right? So these are such ratios which help us to find out the relation between the sides and the angles of a triangle, right? And as the sides and the angles of a triangle are in the same relation, as such, these trigonometrical ratios have a lot of significance, and all through you study trigonometry with them. Well, now the important sum. Okay, so first children, as I'll give you people the sum, I'd like you people to first try it out. I'll give you a little time for trial, and after which I will be discussing the sum. So first try out the sum. I'm giving you a little time to try, right? So this is what it is. Okay, so your time starts now. All the children who are at this moment offline, right, that means they can try it out for a longer duration of time, and all those children who are online, they also require to try this out for a longer duration of time. You can pause the lecture right? And you can take some 3-4 minutes time in which you can try the sum to do it all on your own, right? And if you can't, then obviously look up the solution, and then you also require to do the sum once well. How it has been done, you'll look it up, then you will do it once well, understanding every concept. And if there is some point where you get stuck up, then that is the point where you should look up again and do the sum once more for better assimilation of the concept. Okay children, in the question we've been given here that there is a figure like this which looks like a trapezium, and in this trapezium we have here, these are two sides which are parallel to each other. One is the longer side, which is 14 centimeter, and then we have the shorter side CD, whose length has not been given to us, and we've been given that this angle DBC is phi, right? So obviously the angle which will be this angle DBA, that will be 90 minus phi, right? And here further we've been given that the base BC is of 12 centimeter, and we've got to find out half times of sine phi plus 1/3 of tan of theta. So when we talk about sine phi, we first have to talk about the triangle, which is this triangle, right? And in this triangle we get to see that we have the side which is opposite to phi will become the perpendicular. As such, here we can mark the perpendicular to be this side, right? We'll mark it with small letters. Okay, the side which is the hypotenuse is the side which is opposite to 90 degrees, so this is the hypotenuse, and the third side is going to become the base, right? Excuse me. Now you have the perpendicular, you have the hypotenuse, and you have the base, so obviously you can apply the Pythagoras theorem. Here we get to know that in this figure we have the value of hypotenuse, we have the value of base, so we've got to find out the value of perpendicular. So as perpendicular will be required in finding out sine phi, so we actually require to find it out. So as such, here first what we'll do is we will say that by Pythagoras theorem, right, we have here hypotenuse square, which will become equal to square of the sum of the perpendicular and the base. So as hypotenuse is known here, so we will keep its value, that is 13, right? And we'll square it, and to that is going to be equated perpendicular square, which we do not know, so we will keep it to be b square, and to that is going to be added the base square, which is 12 square. Now children, here further we can calculate this as we will have perpendicular square, which can be written to be equal to 13 square, from which 12 square can be subtracted. So for the children, this will become equal to 169, from which 144 can be subtracted. As such, this will come to 25, and as such p will become equal to 5, right? We won't take the negative value as we're talking about sides, and sides can't be negative, right? So 5 unit is going to be the length of the perpendicular, as we've been given that to be in centimeters. So now we can even write that also to be in centimeters. So this is 5 centimeter, which is the length of the perpendicular. Now children, very simply we can find out what sine phi is going to be, and sine phi, this is going to be the ratio of the perpendicular to the hypotenuse, and perpendicular has been just found out to be 5 and the hypotenuse was 13, so this becomes the value of sine phi, right? Okay, after finding out sine phi, we also require a value of tan theta. For that, now we require a right angle triangle, remember. So what we do is we now talk about a right angle triangle by doing a simple construction. Now what can that construction be? If say we draw a straight line which is parallel to the base BC and drawn from D, then obviously we will have this length, right? And this point can be marked to be, say, some point E, right? And thus we will have DE to be parallel by construction drawn, right? Now we have a right angle triangle, right? And we have the length of CD just now found out to be 5, right? As such, from 14, if you subtract 5, right, so you will get 9 to be this length, which is AE, right? So if we talk about this length, which is AE, this length is 9, right? Okay, so we have this length, and obviously the length of ED, as it is parallel to BC, and as EDCB is forming a rectangle, so obviously the opposite sides will be equal, and this length ED will also be equal to the same as BC, and thus it will be 12 centimeter. So now you have this, right? And very easily, if required, you can find out the value of the hypotenuse, and here we won't require to find out the value of the hypotenuse, as we are talking about tan theta. So we can talk about this side, which is in front of theta, will be the perpendicular, right? And this side, which is opposite to 90, will be the hypotenuse, and the third side will become the base, that is A. And since in tan theta we require perpendicular upon base, as such it will be 12 upon 9, right? So next, now we'll be talking about tan of angle theta, and that will be equal to perpendicular divided by base, and here we have the perpendicular to be equal to 12 and we have the base to be 9, right? I'll just quickly check it out. Perpendicular to be 12 and base to be 9. As such, this is going to become the value of tan. There is a common factor 3 that we'll cancel off, so 3 4s is 12 and 3 3s is 9. As such, we have the value of tan theta, right, which will become equal to 4 upon 3. Now remember, children, we require to find out the value of the expression half sine phi. So now we will talk about half sine phi, to which is to be added 1/3 of tan theta. 1/3 of tan theta. Now in this we will substitute the values, as we have sine phi, which is equal to 5 upon 13, so we write it out here, and to that we add 1 upon 3 times of tan theta that we've just found out to be 4 upon 3. Now we calculate, there is nothing which gets cancelled, right? So as such, here what we do is we will now have 2 into 13 into 3 into 3, which will become the LCM, as there are no common factors. Now here 9 5s will be 45, it will be the numerator of the first fraction, plus you will have here 13 to the 26 into 4, right? 26 into 4, 4 6 is 24, 2 remainder, 4 to the 8 and 2 is 10, 104, right? And now children, if we write this, this is going to become equal to 4 and 5 is 9, then we have 4 and then we have 149 divided by this denominator, which is 13, 2 is 26 into 9, right? So 9 6 is 54, 5 remainder, 9 to the 8 and 8 and 5 is 23, so 234, right? So this, children, is going to become the final answer. So all of this I'll just quickly discuss, so that if there is any doubt, all of that gets cleared. In the question, children, you've been given that there is a trapezium, and in this trapezium, from the measurements which have been given, we've got to find out half sine phi plus 1/3 of tan theta. So here, as such, what you do is, in this trapezium, we first try and find out where angle phi is and where angle theta is. Obviously they should be housed in some of the other right angle triangles. Only then we'll be able to find out the trigonometric ratios regards to them. So now when we talk about this angle phi, right, in this, the side which is opposite to it will be the perpendicular, the side which is opposite to 90 degree will be the hypotenuse, and the third side is going to become the base. So we have the hypotenuse, we have the base, and we do not have the perpendicular, right? So what we do is we can find out the perpendicular by using the Pythagoras theorem. So as the Pythagoras theorem tells us, hypotenuse square is equal to perpendicular square plus base square. So as such, hypotenuse square being 13 square, it will become equal to perpendicular square plus base square, which is 12 square. And further, thus perpendicular square can be written to be equal to 13 square, which is 169, from which 12 square, that is 144, is to be subtracted, which comes to 25. And on finding out the root, we will get the perpendicular to be equal to 5 centimeter. Now after we have the perpendicular, then as you know that sine phi is equal to perpendicular upon hypotenuse, so we divide the value of perpendicular, that is 5 centimeter just found out, by the hypotenuse, which we already knew to be 13, right? So 5 upon 13 becomes its value, and for the time being we leave it as it is, and then we proceed towards finding out what tan theta is going to be. Now for tan theta, we look up, now we have this length, and this length, which can probably form a triangle, but that's not a right angle triangle. So as we require a right angle triangle, that can be formed by dropping a perpendicular from the vertex D on the side AB, right? And when we do so, we get a line which is parallel to BC, and as perpendicular to BC are the sides BA and CD. Thus EDCB becomes a rectangle, and as opposite sides of a rectangle are equal, so obviously this length ED also becomes equal to 12 centimeter. Now we've just found out this length to be 5, and this complete length is 14. As such, from 14, if you subtract 5, you will get 9, right? So 9 becomes the length of AE. In this right angle triangle, in front of theta you have the perpendicular, that is 12 is the perpendicular, and the base will be the third side. So as the side which is in front of 90 is the hypotenuse, that is this, right? So this being the third side will become the base, which is 9. So we have the perpendicular, we have the base. We don't require to find out the hypotenuse, as tan theta is equal to perpendicular upon base. So perpendicular being 12 and hypotenuse and base being 9, so 12 upon 9 will become the value of tan theta. So we have tan theta to be equal to 12 upon 9. Now here further we cancel off the common factors, as 3 is the common factor in the numerator and in the denominator. So 3 3s is 9, 3 4s is 12. So tan theta becomes equal to 4 upon 3. Now children, in this we substitute the values of sine theta and tan phi, that is half times of sine phi plus 1 upon 3 times of tan theta, as is required in the question. So as here we have the value of sine phi to be how much? Sine phi is 5 upon 13, so we keep it here, and then tan theta is 4 upon 3, that too we keep here. And then further we calculate this, we find that there are no common factors in the numerator and in the denominator which can get cancelled. Moreover, there are no common factors even in the terms in which we've got to take an LCM, so it'll be a product of all of these terms. Now we don't multiply it because that will be a waste of time, because again we'll have to divide. So as such, now we look up that in 30 into 2, if we multiply by 3 into 3, that is 9, right? We will get to this LCM. As such, 9 is going to be multiplied by 5, right? Why? Because whatever is this denominator, right, that divides this LCM to get the number which is to be multiplied to 5. I hope you people know this, right? Okay, so further here 9 will be multiplied by 5 to give you 45, and then further you require to multiply these two with 4, that is 26 into 4 to get this numerator. And here we calculate this. 4 6 is 24, 2 remainder, 4 to the 8 and 2 is 10, so 104. Now further we've got to add both of these, so that then becomes equal to 5 and 4, which is 9, 4 and 1. Next we require the product of both of these, so here we have 13 2s is 26, 26 into 9, right? So 9 6 is 54, 5 remainder, 9 to the 8 and 5 is 23, so 234. And children, this becomes the final answer. So is everybody clear about this? For sure. Well, remember, there is a gift for you people, a gift that you can come and discuss what your problem is, and you will get me live solving your problem, right? So there's a form link in the bio. Do click on it, right? And you'll get to see that there is me who is going to meet you people, ask your problems, and tell you how your problems can be solved. Moreover, there are a lot of lectures which you can get helped, right? There are many PDFs which I have, which are actually cheat sheets, so that you can very easily cover up the syllabus of class 9. And here my task is to take you people not just in learning the subject, but in times to come taking you people in a journey from learning mathematics of this class to class 10, class 11, class 12, that is to higher classes, and also providing you knowledge of mathematics of competitions. So it's a journey from getting the proper education in this class to be becoming employed, right? So journey from education to employment, and this journey is going to be full of joy, and that is why I say join joyous journey. So join me in this joyous journey, and surely we'll enjoy a lot. We'll learn a lot of mathematics easily, and you can ask whatever are your problems without any reluctance, and you will see me that I'm always there taking care of you, so that your mathematics can be made more strong and ever strong, and the strongest that it is possible, right? So bye children, I want to see you all get 100 in mathematics. Bye.